Okay. All right, so midsegment of a triangle is our main item for today. And here's the definition of it. Midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. So we don't go from a vertex. I think this is section, you can see we're going to need to construct. Oh, you took two of those last night. I hope you're bringing these back so we can continue using. Looks like we have some more. Looks like we're needing to come over here to get some more. Plastic bag, compass, protractor to put in the bag. Yeah. Okay, definition, got it drawn. Now, this says construct, that's not construction. Okay, so as far as drawing it, you can sketch it for your definition, but in that construction space, we need to actually construct it. And it looks like that's what you're getting ready to do. Okay, construction. You simply need to be able to construct the midpoints, and we've done that construction before. So if you want it to look like what I've got up there, you need to construct the midpoint on the left and right. I think maybe I can just sketch it possibly. So from these two endpoints, go from this end more than half, make the arc, and then from the other endpoint more than half. Connecting those, I didn't quite get my point, but connecting those would locate the midpoint of that side. Do the same on the right side of the triangle. No, I want you to use a compass. I can't use a compass on there. Sketch it for the definition, construct it in the rectangle.
We just draw a triangle.
Yep. Draw a triangle and then construct the midpoints. Someone want me to show that step by step with my compass?
Yeah.
Make yourself a random triangle. Construct midpoints that we've done a number of chapters. You just have to concentrate on what side you are doing the midpoint of. So on the left side, I'm opening my compass more than halfway, where I think the midpoint would be. From each end, draw the same arc, those two arcs to cross. Connecting them. I'm just going to dash it when I connect it. I need that midpoint. If it were a median, I would connect that midpoint to the vertex. But this isn't a median. This now is called a mid-segment. Take the pencil out and sharpen it and sharpen it. Those two will create a midsection. Now, what do you think some properties about that midsegment will be? As you look at your picture, any relationship you think that midsegment has to the rest of the triangle? Think it's the same length as any side? No? Is it perpendicular to any side? Is it parallel to any side? Maybe not perpendicular to the bottom, but maybe parallel to this one? That looks like it? How can we see if it's parallel to the bottom? What guarantees then the lines are parallel? Rechurning, what did we do that came up with parallel lines? Converses of like alternate interiors and corresponding. Okay, you got your tools. Why don't you, on like the right-hand end, why don't you measure this angle? And let's see if the angle that's down in its corresponding position, let's see if those angles are the same. If the corresponding angles are congruent, then the lines will be parallel. Measuring some angles right now. Matt's shaking his head yes. I mean, yours measured the same? Got that too here? Mhm. It sounds like we're coming up with measures that are the same. So one thing we're discovering right now is this mid-segment evidently is always parallel to that side of the triangle because those corresponding angles are congruent. If we measure on the left-hand end, those corresponding angles would be the same also. Okay, the length of it. The length of the mid-segment is related to the side it's parallel to. It doesn't look like it's the same length, does it? Measure how long your mid-segment is, measure how long that side of the triangle is. Maybe metrics would be an easy way to do that, so you go to decimals. What would this side look like? Be called, I don't know what I want to call it, A, B, C. You can call this M and that M. Oh, parallel to, it's the side that doesn't have the midpoint. So I think the theorem is the third side of the triangle, meaning not the ones that you did the midpoint of, but that other side. Okay. Your mid-segment was half of AB? Yes? Yeah? That's what it's supposed to do. The mid-segment's length is half of what the side it's parallel to measures. So that's what we were talking about right there. And that should lead us to the actual theorem. Did that work out? The length in half as much? So if you flip your notes, the actual triangle mid-segment theorem says a mid-segment of a triangle is parallel to a side of the triangle. I guess it just says parallel to a side of it. Obviously, it can't be parallel to the one it connects to, so it has to be that third side. And its length is half the length of that side. Mid-segment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. So which part's the hypothesis? Well, you have to have a mid-segment in a triangle, so that's why I put the picture as the hypothesis, and then the conclusion, I wrote it into kind of symbols. The way I labeled it, DE is parallel to AC, and DE is half of AC's length. We're going to be doing some calculating to really see if that is true or prove that it's true, demonstrate that it's true. What calculation can you do? Like if I give you points on a graph, what calculations would help me prove that the mid-segment's parallel to the side of the triangle? The slope, distance, or midpoint calculations help you show that they're parallel. Slope measurements. What would would help me show that DE is half as long as AC? What tells me how long the segment is? Slope, distance, or midpoint? Distance. Distance tells you how long they are. Yes, midpoint has something to do with lengths, but I can't really use the midpoint to help me get how long DE is. So we're gonna do some calculations with slopes and distances to demonstrate or prove this theorem. Did you get the notes down? Okay. So find the length of the midsegment and what angles are congruent. How long is the midsegment? So the midsegment is half as long as the side that it's parallel to. So figure out what length MS is. I might draw the picture on the thing for that when you'll have it. And what angles in that diagram are congruent? Mark them, mark which ones are congruent, or list which ones are congruent so we can talk about them. First, how long is the midsegment? How long, Lucas? 14 inches, yes, because we had that. Okay, so it's 14 inches in length. What angles are congruent? Which angle S? RSM, so this one is congruent to STN. Why?
Because of the triangle mid-segment here.
Okay, that said that these are parallel. And so those angles are congruent because when you have parallel lines cut by a transversal, those aren't the same side interior, what are those? They're corresponding. Because one is an interior between the lines and the other one would be an exterior, corresponding angles. Okay? What other ones are congruent? RNT, same reason, the parallels, corresponding angle converse. Angle R is congruent to angle R. Reflexive property could be going on there. I don't think that's one that they wanted, but that's one that's there. Question on what we came up with. Okay, let's see what my next screen is. Okay, the vertices of triangle XYZ are those. M and N are going to be the midpoints. We're going to do some calculations now. We mentioned slope and distance formula. I gave you some graph paper. I don't know if it copied off really well there. But graph those 3 points, label them correctly, X, Y, and Z on that little graph paper. Probably put the coordinates so that you know for sure what points those are. X was -1/8. Y is 9.2, and Z is 3, -4. Let's see if I graphed it there. Your graph paper is going to midpoint to midpoint, mid-segment. We're supposed to now show that MN is parallel to XY and MN is half of XY. Well, let's start with this parallel. What are we going to calculate that would prove that they're parallel? Slope, distance, or midpoint? Slopes. Okay, slopes. So which one do the guys want? Guys, you do the slope of MN. Girls, you do the slope of XY. And we'll compare to see if it tells us that they're parallel based upon what you calculate. If you don't know which one I said, just do one of them. Find the slope of one of those line segments. slope. Write down your formula if you need to. Slope of either mn or xy. We'll need that in a little bit, but right now we need slope. Slope, y2 minus y1 over x2 minus x1. It's a fraction, maybe it simplifies. Slope is a fraction, a rise and a run to compare. Guys, is that mn that you're doing? I'm saying -3 over 5. That's it. All right, looking at guys' papers, -3 over 5 was the slope of mn. Girls, I didn't look at your papers too much. What'd you get? -3 over 1. You got -3 over 5. -4 over 5. -3 over 5. I think check your denominators. See if you're doing. Let's just see if you're doing the right thing. X and Y. So you're doing. I think you're using point Z. There isn't. You're using the wrong points. All right, girls. I think it looks like simplified to be -3/5. Okay, if the slopes are the same, what's that mean? Mn is parallel to xy because why? Because their slopes are equal. Some of you kept wanting to use over the last chapter the parallel lines theorem. This is finally the parallel lines theorem. It says if they have the same slope, then they're parallel. I don't know its number, but parallel lines theorem. All right, we did half of the problem. What else are we supposed to show? Supposed to show that mn is half of xy. Distance formula, we need to know how long they are. Okay, so stick with the points you just used. So I think it's guys, you figure out mn. And let's go simplified radicals, not decimals. Mn is how long? Xy is how long? The old distance formula. Got anything for me yet? What's in that?
I think it's square root
Square root of 34?
I got it.
Agree with that? Okay, you got some buddies agreeing with you. Mn is the square root of 34. Girls? What do you get? 34, I'm thinking if I factor it, it's 2 and 17, and that doesn't go any further. Can't simplify it. Girls, what number are you coming up with? Square root of? Anybody wants to say? I think it's a big number. Is it in the hundreds? 164? That look familiar? Yeah? Okay, can that be simplified? 2 and 82, 2 and 41. Can you divide 41 by 17? No?
Maybe. 41
Is it 3 times 17?
and that'd be 51.
Maybe 51, not 41? All right, this isn't doing what it's supposed to do. 164 must not be the right number. Okay. Guys, help us out. Or am I factoring wrong? You got what? 136? Okay, check your numbers and see. 136 maybe? Does that? I know how it's supposed to come out, so I need to reduce it here. 2 and 68, 2 and 34, 2 and 17. Okay, so here's my numbers. What do we do when we try and simplify? How did we know whether it can simplify out? If there was a pair. We got a pair of 2's, but the 2 and the 17, there's not a pair. So back together, that's 34. So is the square root, I'll ask you this, is the square root of 34 half of 2 square roots of 34? That makes sense that it's yes? So I'll change the word. Instead of is, I'll say since the square root of 34 is half of 2 square roots of 34, mn, that's what the square root of 34 was, is half of xy. That's what we were trying to prove. Now when you do these calculations, you need to make sure I can follow your work. I can tell you're calculating mn, xy. You finish it with a comment, what you just figured out. Do your distance formula, the other distance formula. Tell me how that is that one of them is half of the other. This is kind of like a calculating proof. It's called a coordinate geometry proof. I'm not going to make you do it real organized that it's like statements, reasons completely, but you do have to finish the calculations with what those calculations support. All right, so what did we just do? We demonstrated, we really didn't prove the midsegment theorem, but we demonstrated the midsegment theorem works for this triangle. Question on the calculations that I just went through with you. Okay, let's move on then. So I'll make sure that everything matched up. Parallel distance. Okay, so shall we do another sample? You know how to do that. What did you write in your notes? What do you have to do on that problem? First we did what? Okay, well, first thing I did was graphed it. Okay. That might just help you keep track of what you're doing. So make a graph of it. Then we found the coordinates of the midpoints, midpoint formula. Then we found the slope of the midsegment and the side of the triangle. What were we looking for to see if they're parallel? We need the same slope. And the last step we did was length. What formula did we use? Distance formula. And probably if you simplify it in square roots, you'll be able to justify that the one length is half of the other. I'll put some quick notes down and I can come back to this screen once we get to like homework parts. But step 1, graph the triangle. Step 2, find the midpoints. Step 3, find the slopes to see if they're parallel. Step 4, use the distance formula to see if the midsegment's half of the side. All right, and let me know if I need to come back to that after we're through this. Okay, so there was the midpoint and midpoint. I think what the graph will help you do is make sure that you're using the correct points as you're calculating. Compare the slopes to the same. Compare the lengths. Notice how this one came out, square root of 13, and 2 square roots of 13. So again, MN was half as long. Okay, 3 mids there. That's fun, interesting, good. Okay, now there are no numbers up here. Maybe I should put some. If this is 10, then this is 10. How long is the mid segment that it's parallel to? Would the mid segment be 5? What's this whole side? 20. Half of 20? 10. If this whole side is 28, how long's PZ? How long's ZR? How long's the mid segment that it's parallel to? Half of 28, which is 14. What if this mid segment is 12? This whole thing would be 24, which makes 12, 12. Compare those little triangles. Something interesting? See? They're all the same. Even the mid-segment one? 12, 14, 10, 12, 14, 10. They're all congruent by side, side, side congruence. And if we look at angles, didn't we earlier have this angle congruent to this one? Because of your corresponding ones. Okay, well, if I look at these parallels, that angle's also congruent to this one. So those 3 are the same. Which one in the mid-segment triangle is that same angle? YXZ, this one. One thing you could do is look between which 2 sides it is. Also, these, see those 2 are alternate interior angles. So all those green ones are the same. Some of you aren't so excited about this as I am. This angle is the same as this one, and this one, and alternate this one. Those are all the same. And I guess I can do black. This angle is the same as this one, and this one, and this one. There's a lot of relationships in that mid-segment triangle. Some of the problems will ask you to come up with a certain angle measurement. It might give you, this one is 52, and ask you to find some other ones. So looking at the parallels and different things, you can come up with some of those. All right, what else did I have here before we're done? Okay, finding the measures. How long's BD? Notice B's a midpoint, D's a midpoint, BD's a mid-segment. Half of 17, so 8.5. Correct. What's the angle CBD? CBD. Why is it 26? Okay, some of you are looking alternate interior, this angle and this angle, because this mid-segment's parallel to that one. We can make the Z, the corners of that Z are the same. Correct? How about JL's length? See the mid-segment 36? So 72, 2 times 36. PM's length? Which trying to calculate, Ben.
Alternate, interior.
Now, I'm not asking an angle, segment length. How long is this segment? Which one's it related to? It's related to the 97. That was half of 97. So the mid-segment's half as long as the side that it's parallel to. Now an angle. MLK. How big's this angle? Why? Okay, good. We did have corresponding. Because by the theorem, those two are parallel. It's 102. Am I going too fast? Kind of zipping through a few of them here. All right, and this was just an application. Let me kind of go through that one, same thing. All right, so you have to, let's see if we talked about all these. How about the variable one, number 4? How would you do that problem when there's variables in it? Would you set n plus 14 equal to 3n plus 12? Is the mid-segment the same length as that side? That would be one way to do it. The n plus 14, you have to take that times 2 to get it to equal the side over there, because the mid-segment's only half as long. So that would be a way to do that problem. And let's see, did we do orthocenter on the iPad?
Yeah.
Was that the one? I think I know what you're doing now. Take a look at it. That was 0, 2. All right. How about a circumcenter? Circumcenter. What would that be made out of? Circumcenter. If I were you on your note card, that's some of what I would write down. Circumcenter is the 3 perpendicular bisectors. And I'd probably put a little bit